Hey everyone, so this is a quick video to show you how to go about solving these types of questions. So this worksheet is in your OneNote folder. You can take a look at these questions and kind of determine which ones are the most important for you to play around with first. But I will go through a couple of examples just so that you're aware of how to go through them. So let's start over here. Let's do number 26. So 26 has cosine of 2x is equal to root 2 over 2. Okay, so in order to solve these, first of all, we have to identify that there has been a horizontal compression by a half on this. So as a result, we're going to just for right now let theta be equal to 2x for our substitution, but we also need to identify that the new period for this actual graph is not 2 pi, it's 2 pi over 2, which then reduces down to pi. Okay? So we need to have those two pieces of information just to make sure that we are aware of what we're working with. So then we're going to write in the substitution, we're going to use theta for right now, which is equal to 2x, and we're going to have root 2 over 2. Now this isn't in the traditional format that relates to our special triangles, but we can use the fact that if we multiply by a conjugate, we can then have it and reduce it down. So this will become root 4, so that becomes 2 over 2 root 2. The 2's will cross out. That's the same thing as 1 over root 2. So this expression here of cos theta is actually the same as 1 over root 2, which is a little bit easier to identify now with our special triangle. So 1, 1 root 2 triangle with a pi over 4 reference angle. Now cosine is positive in this case here, so because it's positive, we are going to have quadrants 1 and 4 for our possible solutions with a reference angle of pi over 4. So now that we have all those little pieces of information all together, we now can say that theta, where theta 1 is going to equal in quadrant 1 pi over 4, and theta 2, which is going to be in quadrant 4, is going to be 2 pi minus pi over 4. So if you need to see it written out, and that is the reason why for theta 2, we're then going to get 7 pi over 4. Okay, now that's the conversions for theta, or the two angles for theta. Now we have to convert in terms of x. So we know that theta is equal to 2x. So as a result, our first answer, if we say that 2x is equal to pi over 4, we then have to divide both sides by 2, so then we're going to get x is equal to pi over 8. So that would be x1 for this case. And then for our other one, if we have 2x is equal to 7 pi over 4, again, divide both sides by 2, we will then get 7 pi over 8. That will be our second solution. Now, because this question is asking us to solve over the interval from 0 to 2 pi, and our new period is pi, that means between 0 and 2 pi, we are going to get two instances of it. So if it needs to help look at this a little bit, we're looking for solutions between 0 and 2 pi. We have two solutions now, one in quadrant 1, one in quadrant 4. That is 7 pi, oh, sorry, first one is pi over 8. And this would be our 7 pi over 8. We need to then find the two solutions that would fall between pi and 2 pi. To do so, to get our third and our fourth possible angles that are solutions between 0 and 2 pi, we basically add pi to each of these. So it would be x1 plus pi. So in this case, pi over 8 plus pi, which will then give us 9 pi over 8. And same thing here, we'd use our second angle and add pi to it. So 7 pi over 8 plus pi. So then we're looking at here 15 pi over 8. So our four solutions between 0 and 2 pi would be these four here. Another type of question we're going to look at involves solving trigonometric equations that look like quadratics. So let's take a look at another one here. Let's do 42. So If we look at 42, we have cos squared x plus 2 cos x minus 3 equals 0. So in this case here, it does look very similar to a quadratic because you have a cos squared. Now keep in mind when it says cos squared x, that is the same idea as saying cos of x all squared. The reason we put the little squared here is so that we denote that we're not squaring the x term, we're squaring the expression of cos. But you can also think of it in this sort of format, which will help you with isolating a variable and putting in a different substitution variable. So we will sub in, let's say, y that equals cos of x. So then we'll have y squared plus 2y minus 3 is equal to 0. So now we can see quite easily that it will factor quite nicely to y plus 3 and y minus 1 equals 0. Y squared minus y plus 3y, so you get 2y minus 3 equals 0. Now using the idea of the fact that it's a 0 property, this has to equal 0 or this has to equal 0. So if I substitute back in cos x where we see a y, cos x plus 3 has to equal 0, and also we have to consider cos x minus 1 has to equal 0. As a result, here we have on this side cos x equals negative 3. There is no vertical expansion of cos of x, so therefore there is no solution on this one, does not exist. Yet over here, if I write it out as cos x equals to 1, and then we can consider on the cos graph, where are you going to have it equal to 1? Well, we'll have it at 0 and at 2 pi. You can also look at the unit circle as well, or you can look at the actual cosine graph. So now for the interval of 0 to 2 pi, there's no horizontal compressions on this, so we have one entire cycle between 0 and 2 pi. And also in this case here, we are using square brackets at 0 and round brackets at 2 pi, which means that it's equal to 0. Here it is close to 2 pi, but not equal to. So as a result, our solution for this one is not going to be 0 and 2 pi, it's just going to be 0 in that interval. The rest of the questions on this page are going to be questions that are already pre-factored for you, like these ones down here. All these ones are already pre-factored, and then you're just looking to solve over the interval that's given. There are a couple that you do need to factor, such as these ones down here, but finding a common factor similar to 57 and 58 will help you set up and solve these problems. There are some here where you don't necessarily have to factor, like this one's a trinomial. This one here, for instance with 52, if we look at this type of question where we have 4 secant squared x minus 2 is equal to 0, we can start isolating 4 secant squared of x, move the 2 over, and then we divide through by 4, so we get 1/2. Now because we're doing a square root, keep in mind, remember this is the same thing as secant fx all squared is equal to 1/2, so therefore we can square root both sides. But when we square root both sides, remember that we do also want to have the plus or minus square root of 1 over 2, which again, just for working with radicals, that would then be plus or minus the square root of 1 over the square root of 2, so it can be written as 1 over root 2, which then we can then relate to a special triangle, the 1 root 2 triangle, and our reference angle of pi over 4. Now because it's plus or minus, we're looking at all quadrants. You're looking at the positive quadrants and the negative quadrants. So hopefully that helps you get started on this worksheet and considering how to solve different types of problems that have horizontal compressions in them or vertical expansions. Technically these ones have vertical expansions in front of them and shifts, and then we can solve by using these techniques algebraically. Hope that helps.